Hi, I'm Mr. Franklin, and today I'm going to explain one of our problems from our practice test that is really important to understand but causes a lot of confusion for some people. And part of it's just because there's a lot of information in one little spot, and trying to sort out what it all means can get confusing. So to start off with, this diagram shows the position of a pendulum. So a pendulum is a thing on a string, and it swings back and forth. Okay. Um, and so basically we've taken a camera like I've shown you before in class, like a stop motion camera, where we're taking pictures at each second where it is at. So letter A is right here, letter B, letter C, letter D, and letter E. Okay. So first thing, because of conservation of energy, if the energy at A is 60 joules, we don't need to know anything else but, let me make sure I'm not missing anything. And okay, so we are assuming no friction, no damping, no non-conservative forces. Okay, so let me back up. So if the energy is here is 60 joules, okay, guess what the total energy all the way down has to be? Has to be 60 joules here, has to be 60 here, and so this one would be 60 joules. Okay, and then if we do it again, the next one would be 60 joules. Yeah, now we can see it. Okay, and so on. So all of these would be 60 joules all the way down. 60 joules and 60 joules. So potential energy is mgh. mgh, guess what it should be? 60 joules. Why? Do the math. Here, I'm going to add another text box. U equals mgh, and so we have a mass of 3.06, and then we're going to multiply it times a height of 2 meters times 9.8, and if we do that, so 3.06 times 2 times 9.8. 59.976, which if you round it is 60 joules. Okay? 60 joules. But that should make sense, because if the total energy is E, we always know that E is equal to U plus K. So U plus K is equal to that one. So 0 plus 60 equals 60. Okay? So these are all 60. So this one might be we have to think about. There's a little bit more work to it. But if we keep going and doing the ones we know, will be easy. If this is 0, what plus 60 equals 60? Well, it's going to be 60. Okay? Well, guess what it is down here at the very bottom? It's the opposite. It matches. So A and E are going to be the same. So here, let me go ahead and fill this in, because now this is getting confusing because I'm not actually typing. 60 and 60. Which means this one has to be 60 and this one has to be 0. Because U plus K has to equal 60. Well, if you look at letter B, if you actually look at the number, it's halfway down. It's half the height. It's at 1 meter. If you do the math, guess what you're going to get for U? You're going to get 30. It's halfway down, so it's half. So half of 60 is 30. Well, what plus 30 equals 60? So this one's going to be 30. 30 plus 30 equals 60. Okay? Well, this is the same thing. It's halfway down, but it's on the other side of the swing. So 30 plus 30 equals 60. And I know this is confusing because in another thing, we had all this flipped. In our previous paper, we had U, and then we had K, and then we had E. But it's always, and if you need to do this on paper, you could always write this for yourself so you don't forget. U plus K equals E. And then we just do algebra and think through it to work it out. But if the energy we start with has to be the energy we end up with, because there is no friction, there is no damping, energy is conserved. Okay? So let's go down here and look at this graph. What's this graph going to be? Well, this is the total energy. So if I graph the total energy, let's switch to drawing. What's the total energy? At 0, it's 60. Oh, it's height. Okay? So at halfway down, the energy is 60. At 1 meter, it's 60. At 1.5 meters, the energy is 60. And at 2 meters, the energy is 60. Okay? So that's the total energy. Now let me switch colors here. If I were to graph the potential energy, so here, let's do a key first. So this is E. If I were to graph the potential energy, at 0, what's the energy? It's 0. So that's potential energy. And then at 2, we have our maximum potential energy. And at each of these points, so let's see, where's halfway? This is halfway, so there's 30. And then this is halfway between, and we're just doing this by logic here. This doesn't quite line up with the numbers up top, because up top we only have 0, 1, and 2. It doesn't have these middle points. And then we could take our straight edge if we were doing this on paper, and we could actually draw a line of fit, which, excuse my line of fit, because I'm drawing it with a mouse. Okay, actually, do they have a line tool? Shapes. Yeah, there we go. A line. Let's make it pink. And let's do this the right way. There we go. Okay, and there's our line. Here, let's do this one. There's E. This pink one, though, is U, because at the maximum height, it's maximum energy. So let's change colors again, and let's do green. And kinetic energy. At 0 height, the kinetic energy is the maximum. Okay? At 2 meters, kinetic energy is 0. This is harder to see. In the middle, it's at 30, and so it's halfway between there, and then halfway between there, and now we're going to draw a line of fit. And that is K. So this green line is the kinetic energy, the pink line is potential energy, and the black line is energy. Okay, so that's what this table is showing us. The total energy is 60, the potential energy at the maximum is 60, then halfway down is 30, and then at the bottom is 0, and then as it goes back up, it goes 30, and then 60, and then the kinetic energy is inverted. It's 0 at the ends, and then 30, 60 at the bottom, maximum energy, 30, and 0. Now we could actually take this information and we could actually, let's draw, we could take this information and we could actually calculate the velocity of the pendulum if it's at 60. We can actually figure that out because K equals 1/2 mv squared. We know the mass. We could actually work the problem backwards. The good news is you should know that, but we're not going to make you do that for your exam. So I don't think. That was also what we did on the last problem on the last homework. So, all right, that's all I've got for now. Take a look at that. If you have any questions, please message me. All right, thank you.